Hello. This is the last article of this our favorite topic, straight line, and that is family of lines. We have learned lot of concepts of straight line, but at last this family of lines is also very much important article in coordinate geometry. Let us see the definition, common definition of family of lines. The common definition of family of lines means it's a set of lines. A set of lines which satisfy the same property is called as family of lines. In this definition, the condition is given that set of lines satisfy the same property. But what is that same property? Same property means from these words we do not understand easily the meaning of this family of lines. For that, we will go to the basic exam given by Euclid. Let us see once again that to draw a line, if we want to draw a single line, then for that we need at least 2 points. The conditions to draw a line are at least 2 points or 1 point and its duration. These are the two basic needs to draw a line. But suppose 1 point is given, then its duration means, in our mathematical meaning, the duration means, mathematically we write duration as slope, or it is equal to m. So slope gives us duration, and the 1 point means is obviously coordinates of points. So whenever coordinates of a point and slope of line is given, then and only then we can draw a fixed line. Otherwise, if 2 points are given, then we can fix a line. Let us see this second situation. If suppose in second situation, if only 1 point is given, then what will happen? We will consider first situation of point here, and the second situation will be slope. So whenever point is given, then can we draw line? Obviously, suppose a fixed point, that is origin, is given. Means initially we will take this point as origin, that is 0, 0. If point is given origin, then we can draw number of lines passing through this fixed point. That is, this is a line which passes through origin. This is another line which passes through this origin. This is a line which passes through origin. This is also a line which passes through this origin. Or we can draw line this which passes through this. So whenever this origin is given, we can draw infinite number of lines. Means only if point is given, then we can't fix line passing through that point, because there are infinite number of lines passing through single point. So first one, if point is given, that is origin, then there are infinite number of lines passing through this origin, and the equations of lines passing through origin will be y is equal to mx. So this, for different values of m, we get different equations of lines. So this n is a real number. So for this real number, we can write or we can draw infinite number of lines passing through origin. Suppose in another case, instead of origin, suppose certain point is given, or non-origin point. If non-origin point is given, then suppose point is given 2, 3 here. Point whose coordinates are given 2 and 3. Then also we can draw line passing through these points. In this way, we can draw number of lines passing through the same point, this. So this point 2, 3 is a point of intersection of all these lines passing through this point 2, 3. So whenever non-origin point is given, what will be the equation of line here? Equation of line passing through this, but slope of line is not given, so we have to consider that slope as m. So equation will be y minus y1 equal to m into y minus y1 equal to m into x minus x1. Using this equation, equation of line is y minus 3 equal to m into x minus 2. So this is the equation of family of lines which pass through point 2, 3 and having slope m. And the slope of line is m. So changing values of m, we can change the line, but it passes through only 2, 3. Always 2, 3. So this is the equation of family of lines. This is also equation of family of lines. In this way, if certain point is given, then we will get the equation of line passing through that point. So the set of lines which pass through the fixed point is called as the family of lines. So instead of this satisfy the same property, we can write here which pass through a fixed point. But if when we think about point, then we get this condition that if line passes through fixed point, then it's a family of lines. But if you think about slope, then let us see what happens here. About slope. Suppose if we fix the slope of line, then if we fix the slope of line, then we consider first one again condition that having slope. Here origin we have taken first point, we will take here slope as 0, m equal to 0. If suppose slope is equal to 0, then slope of line is 0, then x-axis, its slope is 0, its equation is y equal to 0. If you draw another line which is parallel to this x-axis, then its slope is 0. If the number of lines which are parallel to x-axis, the slopes of all these lines is 0. So these are the some lines having slope 0. We know better the equation of line which is parallel to x-axis, its equation will be y is equal to, if suppose here is 3, here is y equal to 2, y equal to 1, y equal to suppose minus 2. Here is y equal to minus 1, let us say this as minus 3. Then these are the equations of line which are parallel to x-axis. So from this we can see that it's a set of line having equation y is equal to k. So y equal to k is a family of lines. For different values of k, where k is a real number, for different values of k we get the number of lines which are parallel to x-axis. So it's a family of lines of parallel lines. So it's a family of parallel lines. Similarly, let us take another one. If n is non-zero, then what will happen? If slope is equal to 0, we can take either y is equal to k plus or minus. Here, if n is not equal to 0, then if you consider this system once again, then in this system, slope is not 0, so that line may be like this. Suppose making angle 45. So we can draw here number of lines which are parallel to this line. So this is our first initial line L making angle 45. Or we can take line this L as passing through origin and making angle 45. Line will be y is equal to x. You know that the slope is equal to 1 because tan 45 is equal to 1. So the equation of line will be y equal to x. So there are again infinitely many lines which are parallel to y equal to x whose slope is not equal to 0. So if you consider your equation y is equal to x, then this is line, given line, and what will be the equation of line? The equation of line parallel to y equal to x, it may be y equal to x plus k. For different values of k, because here intercept of this line is 0, intercept of this line is this. See, intercept of second line, this will be this much. Intercepts changes only, positive or negative intercepts. So y is equal to x plus k, means here we have fixed the slope, that is 1. So for different values of y intercepts, we get family of lines having slope 1. So this is the equation of family of lines whose slope is 1 but having different intercepts. Obviously they pass through different points. So if we fix the slope, then we get family of line. If we fix a point, then we get another family of lines having different slopes. Whenever point is fixed, slope will be different. If slope is fixed, 0 or non-zero, then point will be different. So we get the second condition, that a set of lines which pass through a fixed point, or obviously in the second condition we get all parallel lines. So line which pass through a fixed point or which are parallel to each other. So we get this as the exact definition of family of lines. So initially we have defined family of lines as a set of lines which satisfy the same property. What is that same property? That same property will be either lines pass through a fixed point or which are parallel to each other. So this first condition is about point, second condition is about slope. So if that set of lines either satisfy this condition or this condition, then we get family of lines. So family of lines are nothing but the lines which pass through fixed point. Obviously we call the lines which pass through a single point as concurrent lines. So all these lines are nothing but concurrent lines. So concurrent lines is a family of lines, and the lines which are parallel to each other, the second is parallel lines. So there are two types of family of lines. One is concurrent lines and second one is parallel lines. Let us see some examples related to this. So from this theory, we have remembered that family of lines is nothing but the concurrent lines or parallel lines. Let us see one example. Find the equation of line parallel to the x-axis. First example. Find the equation of family of lines which are parallel to the x-axis obviously what is given here? Parallel to x-axis means its slope is 0. That is given here. Now we will find the formula to find the family of lines, or what will be the actual equation of family of lines. Collecting all those situations, we will derive now one single equation which will lead to the equation of family of lines. For that, let us consider here in this xy system. Let us consider that this is one line L1 whose equation is u equal to 0. This is the equation of first line, and L2 is another line which may, suppose from first situation concurrent lines, then this L2 is a line whose equation is v equal to 0. sometimes that L2 may be parallel to L1. So I will draw here two lines L2. This is the same line L2, or instead of this line we are taking this L2, which is V equal to 0. So whenever first line L1 is given, L2 may intersect each other or L2 may be parallel to that line L1. So these are the two situations. If intersects, then we will get concurrent lines. If parallel, then we get set of parallel lines. So if this line L1 is U equal to 0, let us consider the equation of L1 as equation of line L1 is U, that is A1x plus B1y plus C1 equal to 0. We are taking this equation in general form. Consider another equation of line L2. It is V equal to A2x plus B2y plus C2 equal to 0. So these are the equations of two lines. Let us try to write here this equation, U plus KV. If you find U plus KV, then what is U? U is A1x. Earlier we will consider. So A1x plus B1y plus C1 plus K into A2x plus B2y plus C2. Obviously, if you take here U plus KV equal to 0, then we get here, let us again collect the terms of x, that is A1 plus K into A2, that is x term. Okay, collect y terms. Y terms, the coefficient of this y is B1, coefficient of this y is K into B2. So here we get K B2. Now consider the constants. Constants are these two, C1 plus this C2 is not alone, K is with it, so we get K C2. This as constants equal to G. So this is the equation which contains this x term, y term and constant. So if you observe this equation, then this is again linear equation in two variables x and y. Obviously, this is a linear equation in x and y. Therefore, it's a line. So what we get here? We have given two lines U equal to 0 and V equal to 0. Then from that we have found this U plus KV equal to 0. And this U plus KV equal to 0 is again a equation of line. Obviously, for this value of K, we will get another line. Means initially these two lines are given. They may be parallel or intersecting, but we get third line from this equation U plus KV equal to 0. Let us see about now slopes of all these lines. Then from that we can calculate certain result. Here slope of line U is equal to minus A1 upon B1. It is slope of U is equal to minus A1 upon B1. What is slope of V? Line V. Slope of V is equal to, from this, minus A2 upon B2. It is minus A2 upon B2. If, now these are the two slopes. If we take the slopes of these two lines as same, suppose slope of U1 and slope of U and slope of V are equal. Suppose let slope of U is equal to slope of V. Slope of U equal to V means, it means line U is parallel to line V. Now we are considering this situation that these two lines are parallel lines. If these two lines are parallel, then the slopes are equal. So we get here minus a1 upon b1 equal to minus a2 upon b2. But here, if we apply the property of equal ratios, have you learned that theorem or property of equal ratios? Here, these two slopes are equal. That means two ratios are equal. So applying the property of equal ratios, we can write this as minus a1 plus ka2. We can take the multiple of these two, or instead of that I will just write first one, that minus a1 upon minus b1 equal to minus ka2 upon minus k b2, multiply numerator and denominator by k. Now add these two, subtract these two, so that we get here minus a1 plus ka2 upon minus b1 plus k b2. Let us see here. So only take here, multiply this by k. So no need to write here double negative sign, not minus k. So it is only negative of that, negative of k2 upon k. So we get here, taking this negative sign common, we get this. Is it okay now? So from these two equal ratios, we get this by using property on equal ratios. If we observe this here, then the slope of this line is, it's a line having slope m equal to. Find the slope of this line. Slope of line is nothing but the negative of ratio of x coordinate, coefficient of x upon the coefficient of y, that is b1 plus k. That is the same here. So this slope of this line is equal to the slopes of these two lines. So this is the line which is parallel to u and v. So line u plus kv is parallel to this. These two lines u and v. So this equation gives us the equation or equation of family of lines which are parallel to u and v. Let us see up now second situation. In second situation, suppose lines u and v pass through point p x1 y1. Okay. Now as line u pass through point x1 y1, what will happen? This point will satisfy the equation of line. Am I right? Because point lies on line, so it satisfies the equation of line. So we get here a1 x1 plus b1 y1 plus c1 equal to 0. Why this? Because point p x1 lies on line L1. Also point p x1 lies on line L2, so it satisfies the equation of line L2. So x1 y1 satisfies that equation, means we will put instead of xy x1 y1, so that we get equation as a2 x2 x1 plus b2 y1 plus c2 equal to 0. Is it okay? So this is considered here. Then as the value of this equal to 0 and this equal to 0, let us check about this equation. This is the equation of line, or this is the equation of line u plus kv equal to 0. What will happen if point x1 y1 lies on this line? Then it will satisfy the equation. So as point lies on x1 line u and v, so we can put here from this equation we get here a1 x1 plus b1 y1 plus c1. Means here what we are considering, let us check whether point x1 y1 lies on this line or not. If we put x instead of x1 y1, and if we get the same answer 0, then that point x1 y1 will lies on this line. So let us put x instead of xy, we are putting x1 y1 here in this equation, which is the equation of line u plus kv. So we get a1 x1 plus b1 y1 plus c1 plus k into a2 x2 plus b2 y sorry a2 x1 plus b2 y1 plus c2. Let us check whether it is 0 or not. That we have to check here. Obviously, from this equation 1, as point P x1 lies on line L1, so it satisfies this equation. So the value of this a1 x1 plus b1 y1 plus c1 is equal to 0. So you get this as 0. Plus this point P x1 y1 lies on line L2. So this point also satisfies this equation that we have written here. Therefore, a2 x1 plus b2 y1 plus c2, it is equal to 0. So we get here k into 0. Now obviously it is equal to 0. So that point x1 y1 also satisfies the equation of this line. So u plus kv equal to 0 passes through p x1 1. So whenever two lines L1 and L2 pass through point P x1 y1, line u plus kv equal to 0 also pass through the same point x1 y1. So this is the equation u plus kv equal to 0, which gives the family of parallel lines having equal slopes, or the family of lines which pass through point x1 y1. For different values of k, we get number of lines which pass through this point, like this. Or if these lines u and v are given, then u plus kv is the equation of lines which represents the number of lines which are parallel to these two parallel lines u and v. So we get the single formula or equation of family of lines, that is u plus kv equal to 0. So the equation of family of lines is u plus kv equal to 0, where u equal to 0 and v equal to 0 are given initial two lines, and this k is a non-zero real number. Then we get the equation of, family of lines. So this is the important formula or equation of family of lines. Is it okay? Now we will solve some examples related to this family of lines. Let us see two examples on these two articles, that is family of parallel lines which are concurrent lines and parallel lines. Let us see example number 1. Find equation of line parallel to the x-axis and parallel to the x-axis and which pass through the point of intersection of lines. Let us see the two lines x plus y minus 2 equal to 0 and 4x plus 3y equal to 10. These two lines are given. If you read only half example, then we get different result. Here find the equation of line parallel to x-axis. Obviously it's y equal to constant. But the second condition is also given, that which passes through the point of intersection of these two lines. If you read only the equation of, if you find the only equation of line which pass through the point of intersection of lines, then we get the concurrent lines. Okay. So obviously here we will get the two different situations. Here we get the family of parallel lines, here we get the family of concurrent lines. But we want here the equation of line. means equation of single line. Here word line is given, not lines. It's not family of lines, it's single line. We want to find here single line, but we will use the concept of family of lines here using this equation u plus kv equal to 0. Let us start with this solution. Here what will we do first? We will first consider these two lines as u equal to 0 and v equal to 0, and from these two lines we will write the equation of family of lines. So consider u equal to this, that is x plus y minus 2 equal to 0 is our first line, and v is 4x plus 3y minus 10 equal to 0. Consider u equal to 0 and v equal to 0 be the given two lines. Okay, therefore the equation of family of lines, passing through the intersection of these two lines is u plus kv equal to 0, where k is maybe 0 but k is a real number. Okay, so k is a real number. So put these two equations here, we get x plus y minus 2. We will put only non-zero part here. If we put with 0 equal to 0, then it will be 0, 0 plus kb equal to 0, it's obvious. So to the right 0 is there, so write only the left part in u equal to 0, u equal to x plus y minus 2 plus k into, what is the non-zero part of this equation v, that is 4x plus 3y minus 10, and the whole is equal to 0. So this is the equation of required line, but here k is unknown. So considering this second condition, we get this equation of line in which k is unknown. If we use this first condition, then we will obtain k, and that will give us the required equation of line. So what to do now here? The equation of line, we need the equation of single line. This is the equation of family of lines, and we need only single line which is parallel to x-axis. What is the meaning of parallel to x-axis? The meaning of parallel to equation of line or line parallel to x-axis means its slope is 0. Because slope of x-axis is 0, equation of line parallel to x-axis, its slope is also 0. So we will take the slope of this line as 0. For that, let us correct the x terms and y terms. So here x term is 1 plus 4k into x plus, here coefficient of y is 1, so 1 plus 3k into y plus, we will write always plus sign, and in bracket we will write the constants with their signs. So minus 2, here is minus 10k equal to 0. So this is the equation of line in general form, which contains x term, y term, and constant. This is the coefficient of x, here is the coefficient of y, and this is constant. These coefficients of x, y, and constant are in terms of k, because k is unknown here. Now can we find the slope of this line? Slope of the line is nothing but the negative ratio of coefficient of x upon and coefficient of y. So here slope of line u plus kv equal to 0 is n, and it is equal to negative of the ratio 1 plus 4k and 1 plus 3k. ratio of coefficients of x and y. So this is the slope of line u plus kv equal to 0. But the line which passes through the point of intersection of these two lines, that line must parallel to x-axis, means its slope will be 0. So from given condition, therefore by given condition for the required equation of line, slope m equal to 0. Therefore, minus of 1 plus 4k upon 1 plus 3k is equal to 0, which implies this denominator will cancel, remains negative, negative sign also will get cancelled, so we get 1 plus 4k equal to 0. Because this ratio is 0, so numerator will be 0, which implies k is equal to minus 1/4, and that is the important value here. Because in the first step we have written the equation of required line, but the unknown is only k, so k is equal to minus 4. Just put that k equal to minus 4 in this equation, we will get the required equation of line. So we will write here, this is equation 1. I can give equation of 1 here, 2 here, then 3. Now put the value of k equal to minus 1/4 in equation 1. Therefore 1 plus 4k, that is 1 plus 4k, k is minus 1/4 x, plus 1 plus 3k, 1 plus 3k, k is minus 1/4 1, plus minus 2 minus 10k, and is equal to 0. Is it okay? What we have done here? We have put the value of k in this equation, so that we will get the equation of line. Here 4 will get cancelled. This is plus 1 and this remains minus 1. Plus 1 minus 1 get cancelled. We get here 0x. Plus here is minus 3/4. So this will be 1/4 of y. By simplification get 1/4 y. Here minus minus plus, so 10/4. So minus 2 minus 10/4, it will be minus 18/4 equal to 0. No need to simplify because 1/4 is here. The number 4 is here, so we will keep here 4 as it is. So it will be, sorry, not minus 18, this will be plus 10 and minus 8, so 2. It's a plus 2/4. Minus 8 plus 10. So plus 2/4. Multiply both sides by 4, we get, obviously this term will eliminate here, remains only y plus 2 equal to 0. So that we get y equal to minus 2 or y plus 2 equal to 0. We understood this equation better. Y equal to constant, because the line is parallel to x-axis. So whenever line is parallel to x-axis, its equation will be y equal to constant. So the question remained only to find the value of that constant, and that can be obtained from these two given equations of lines. So this is the way to solve such examples using the formula of or the equation of family of lines. Otherwise, in different way also we can solve the same example, because two lines are given. If we solve these two lines simultaneously, we will get a point, and that point will be obviously y equal to, its y coordinate will be minus 2. If y is equal to minus 2, then minus 4, so x will be plus 4. 16 minus 6, that is it. So point will be 4 minus 2. So the finding the point of intersection of these two lines, instead of this method, if we use previous method, then solving these two equations we will get the point of intersection of lines. Now the line parallel to x-axis and passing through this point, obviously it will be y equal to minus 2. We will reach to the same answer. Still we have solved this problem using this family of lines. Okay, let us see one more. Find the equation of line passing through the point of intersection. Example number 2. Find the equation of line which passes through the point of intersection of lines x plus y minus 2 equal to 0, 0 and 2x minus 3y plus 4 equal to 0. This is first information. And making intercepts and making x-intercept x-intercept 3 or making intercept x-intercept 3. Obviously making intercept 3 on x-axis. Let us use the same family of lines once again. Here consider these two equations as u equal to 0 and v equal to 0. Let u is x plus y minus 2 equal to 0 and v is 2x minus 3y plus 4 equal to 0. B given to intersecting lines. Therefore, the equation of family of lines passing through the intersection of these two lines is u plus k equal to 0, where k is a real number. So that equation will be x plus y minus 2 plus k into v is 2x minus 3y plus 4 equal to 0. So this will be the equation of family of lines. But here only your k is unknown, that we have to find. For that, the condition is given that it is making x-intercept 3. So just first we will simplify this equation and we will find the x-intercept of this line. So here we get coefficient of x is 1. So here we get 1 plus here is 2k out of bracket x. What we have done? We have collected x terms. Then y terms. Here coefficient of y is 1. So we get 1. Here is minus 3k. 1. Next constants minus 2 plus 4k. is equal to 0. This is the equation of line in general form. Here is x term, this is y term, and this is constant. Coefficient of x, y, and constant, these three are in terms of unknown k here. Now, what condition is given? That line is making x intercept 3. So, find x intercept of this line. What will be x intercept? For that, we have to convert this equation in double intercept form. Take this constant to the right and take it to the denominator. Or if you know better the formula for x intercept, it is minus c upon a. This is c, this is a. From that also you can write directly x intercept. Formula for y intercept is minus c upon this b. Otherwise, use calculation of finding or converting the equation of line in general form to double intercept form. So, therefore, this can be written as 1 plus 2k x plus, I will just write those steps of converting this equation into double intercept form. Taking whole this term to the right, it becomes negative. So, I will write here plus 2 minus 4k. Now, divide each term by that 2 minus 4k, so that we get here this is equal to x upon this 2 minus 4k upon this coefficient 1 plus 2k. This is a or x intercept plus y upon this 2 minus 4k upon this 1 minus 3k. So that this will be y intercept equal to 1. Now this is the equation in double intercept form. So that this is the x intercept and this is y intercept. Here the condition is given that x intercept is 3. As x intercept is given 3. Therefore, this 2 minus 4k upon 1 plus 2k is equal to 3. Is it okay? Let us simplify this. So, 2 minus 4k is equal to 3 plus 6k. 3 plus 6k. Taking this 6 to the left or take this k to the, we get 10k equal to minus 1. So we get 10k equal to minus 1, which implies k is equal to minus 1 upon 10. So this is the value of k. That is important to find. Because this without k we can't find the equation of line. Now this is the equation of line. Call this as equation number 1, because we have not supposed here equations 1 and 2. So this is equation 1, 1 plus 2k. Put the value of k in this equation 1. Now putting value of k in equation 1, we get, so we get 1 plus 2k, that is 1 plus 2 into minus 1 upon 10 x plus 1 minus 3ky, 1 minus 3k, k is minus 1 by 10, 1 plus minus 2 plus 4k, minus 2 plus 4k is equal to 0. Okay. Now simplify this. This will be minus 2 by 10. So 10 minus 2, that is 8 by 10. So this is 8 by 10x. Now simplify this, because in each term 10 will be at the denominator. So here is plus 3 by 10. So 10 plus 3, that is 13. by 10 1. Here will be minus 2 minus 4. So this will be minus 20 minus 4, that is minus 24 by 10. Check the calculations. If certain number will be wrong, then you can correct it. Here multiplying each number by 10, we get 8x plus 31 minus 24 equal to 0. And that will be the equation of a required line which passes through the intersection of these two lines, and whose intercept is 3. Whose x-intercept is 3. X-intercept will be 24 upon 8, that is 3. And that will be correct. So this is the way to solve such examples using equation of familiar lines. Okay. Now we will stop here. This much is about familiar lines. If possible, in the next lecture, we will solve some additional examples on or different examples on whole topic. Okay. Thank you.